Hi there, on this screencast I'm going to do the sample multiple choice questions for the final exam. So let's get to it. Okay, in the first question I'm asked to find the vertical and horizontal shift of this function. Okay, the horizontal shift is always going to be the number that comes after x, and it's going to go in a direction that's the opposite of the sign. So here I have plus 10. That means I'm going to go 10 to the left, and then the y shift is always the number that is tacked on to the end, and it's going to be the direction is going to be the same as its sign. So for vertical, plus is up, so that means I have up 3. Okay, in the next question, I'm asked to factor an expression completely. So this is a quadratic expression. When I'm asked to factor, I always want to look for a common factor before I do anything else. And frequently that'll make the problem much easier after you factor out a common factor. So I can see here that I can divide all of the terms by 3. So I'm going to do that and pull out the 3. So I divided out the 3, and now I have a simple trinomial to factor with a leading coefficient of 1. So I'm looking for two numbers that multiply to be -4 and add up to +3. Well, that would be +4 and -1. So that means I'm going to do v plus 4 and v minus 1. Okay, number 3. Expand the logarithm. Oops, and I misspelled expand. Oh well. Okay, so when I expand a logarithm, first of all, I look for multiplication and then after that I'm going to look for exponents. So when I have multiplication, that becomes addition when I expand. So expand is to write the argument as individual logarithms. So the base always stays the same. All right, and now the last thing I do is I look for exponents. And if I have exponents, the exponent becomes the multiplier, the coefficient. So I'm going to be left with 6 log base 9 x plus 5 log base 9 y. Now, if this was division, it would become subtraction. So just keep that in mind. So that would be my answer. Okay, now I'm asked to condense into a single logarithm. So here I'm asked to do the exact opposite. Okay, so really divided by 2 for those logs there really means I have this. Okay, dividing by 2 is the same thing as multiplying by 1/2. And now my coefficients become the exponents in the argument. So I'm going kind of in the reverse order as I was before. So this becomes the exponent. So now I'm up to log base 3 x to the 1/2 plus log base 3 y to the 1/2. And then lastly, I have addition, so I can condense into a single logarithm that multiplies all the arguments together. So, and notice that the base always stays the same. It doesn't change at all. So just to get things alphabetical, I'm going to do x, y, z. Okay, because that's addition, it becomes multiplication of the two arguments. And then that's my answer. Okay, solve each equation by factoring. So to solve by factoring, I need a 0 on one side of equal sign. So I'm going to move the 18 and the 3x over to the left side of the equation. And I'm going to do that by subtracting 18 from both sides and adding 3x to both sides. So that causes those to drop out. And now I have x squared plus 3x minus 18 equals 0. All right, now I'm going to be looking for two numbers that multiply to be 18 and add up to 3. So that would be positive 6 and negative 3. So I do x plus 6, x minus 3 is the factored form of the equation, and that means either x plus 6 is equal to 0 or x minus 3 is equal to 0. And so I'm going to subtract 6 here and add 3 to both sides here. And I end up with x equals negative 6 or x equals 3. So my solution set is negative 6 and 3. Those are both solutions. And if I substituted those values back into the equation, I should get a true statement. So like if I put 3 in, I get 9 equals 18 minus 9. 9 equals 9. That's true. And if I put negative 6 in, I get 36 equals 18 plus 18. Sure enough, that is 36. So I can be rest assured I got the solution. Okay, so now I have something that's in quadratic form. So to factor something in quadratic form, I factor it as if it was in a quadratic, meaning an exponent of 2. I follow those same factoring patterns. So this is a difference of perfect squares pattern, which is really something like a squared minus b squared is equal to a plus b times a minus b. So that means I'm going to have x. Now, instead of squared, because I'm talking to the fourth power, I make that a 2. So x squared minus 5 and then x squared plus 5 equals 0. Okay, so now I'm going to set each factor equal to 0 and then solve by taking square roots. So that means x squared minus 5 equals 0 and x squared plus 5 equals 0. So I'm going to solve those equations by taking square roots. So I can use that technique when I have no x linear term, meaning no term that it has the variable to the first power. And to do that, I need to get the number, the constant, on one side of equal sign. So it's not like solving by factoring where you want a 0 over there. It's you want to move the constant over to the right side of the equal sign all by itself. So for this one, I get x squared equals 5. And for the other one, I'm going to subtract 5. I get x squared equals negative 5. Okay, so now I'm going to take square roots of both sides of the equation. And I'm going to get plus minus. I can't forget the plus minus sign. And then, so the square root of anything squared, those are reverse operations. So I just get x equals plus or minus root 5. And then here I get x equals, now plus or minus square root of negative 5 is plus or minus I root 5. Remember, when you have the square root of a negative number, you make it positive and write an I in front of it. So that means my solution set is going to be plus or minus root 5 and plus or minus I root 5. All right, so I have two real solutions, two imaginary solutions. Okay, so solve by factoring in the quadratic formula. So I need two formulas here, which you'll get on the test. And one of them is the difference of perfect cubes. So that means I'm going to get a cubed minus b cubed is equal to, and the formula is a minus b times a squared plus ab plus b squared. Okay, so really I have x cubed minus 3 cubed because 3 cubed is 27. So that means for this formula, I'm going to put x in for a and 3 in for b, and then just rewrite out the expression. So that's going to give me x minus 3 times x squared plus 3x plus 9. Okay, and that's all equal to 0 because equal to 0. Okay, so now I'm going to solve by using the quadratic formula. Is going to be one resolved in two of my solutions, and another solution is going to come from the first factor. So I set each factor equal to 0 like I normally do when I'm solving by factoring. And for the first one, it's pretty easy. For the first factor, I get x equals 3. Now, for the second one, I'm going to have to use the quadratic formula. It kind of looks like you might be able to factor this, but trust me, you're not going to be able to. So the quadratic formula is when you have ax squared plus bx plus c. Well, that means the solutions are x equals negative b plus minus square root of b squared minus 4ac all over 2a. Okay, so in this case, my a is 1, my b is 3, and c is 9. So I'm going to get x equals negative 3 plus or minus the square root of b squared would be 9 minus 4ac is going to give me 36, and that's all over 2 because 2 times a is 2. Okay, so I can simplify. So I'm at negative 3 plus or minus the square root of negative 27 all over 2. Okay, so let's see. Negative 27. That's 3 times negative 9, and then 3 times 3. So I'm talking square root, so I'm going to rewrite negative 27 as 3 times 3 times, 3 times 3 squared, because I'm trying to rewrite the factors to the same power as what the index of the radical is. Okay, so that's going to give me negative 3 plus or minus the square root of, and I'm just going to write I out there because I know I have a negative number I'm taking the square root of it. 3 squared times 3 all over 2. So that's negative 3 plus or minus I, and I bring out a 3. So it's going to be 3I root 3 over 2. So those are my other two solutions to the original equation. They're imaginary. And that's what you'll always get when you solve a cubic equation that's in the form of the sum or difference of perfect cubes. So I get three solutions. One is 3, and the other one, what did I say it was? Negative 3 plus or minus 3i root 3 over 2. So negative 3 plus or minus 3i root 3 all over 2. Okay, good. Next one. So that's a pretty relatively lengthy problem. Okay, solve by taking square roots. All right, so this one's simpler. So remember, by taking square roots, I need to get the squared term all by itself on one side of the equation. So in this one, I'm going to divide by 5. So I get r squared equals negative 8. And now I do the square root on the left, the plus minus square root on the right. So that gives me r equals plus or minus, now 8 is 2 and 4, and that's 2 and 2. And I'm talking square root, so I'm going to write 8 as 2 times 2 squared. Okay, so when I do the square root of 8, negative 8 I should say, I'm going to have an I out there, and then I'm going to I have a 2 out there, so I'm going to get 2i root 2. So that means my solution set is going to be plus or minus 2i root 2. Okay. Simplify. Okay, so here we go. I don't know if you remember the order that I do when I'm simplifying radicals. I always go 0 exponents, and then I do power of a power, and then I do the multiplication rule. Actually, no. Before I do that, I think I do negative exponents. And then I do the multiplication rule, and then I do the division rule, and I think that's pretty much it. Okay, so I don't have anything to the 0 power here, and I don't have any power of power. That always involves parentheses when you multiply exponents. So I'm going to do the negative exponent rule first. So basically, I just need to sort out whatever's there, and if it has a positive exponent, I leave it in the numerator, and everything else goes down to the denominator. Now note the coefficient is independent of all the variables unless you have parentheses around it, which we don't. So here I'm going to get m to the positive 4, and then m to the positive 3, and then n squared. So those are my negative exponents. And now I'm going to do, I'm going to use the multiplication rule, which is when you have repeated bases. So in the numerator, I have repeated n squared, so I add the exponents together. In the denominator, I've repeated m's, so I add their exponents together and condense into a single exponent. Okay, so now I'm going to use the division rule, and let's see, I have 2 m's at the top, 7 n's down below. If I kind of think of it as this, seven m's down below, 2 up top, I can cross out 2 of them, leaving me with 5 in the denominator. So negative 4 over m to the 5th. And likewise, with 4 n's in the numerator and 2 in the denominator, I'm going to cross out 2 of them and leave me with 2 in the numerator. And then that's my solution. Okay, so number 10, very similar, except I already have something in the denominator. So I'm going to do 0 exponents. There's nothing that has a 0 exponent here. So the next step for me would do power of a power. There's nothing here with parentheses, in which case I'd multiply the exponents. So now I'm going to go and do my negative exponent rule, and that means this is going to go up and this is going to go down. So after I do that, I'm going to have m cubed n cubed times 2 m cubed, and the n negative 2 comes up into the numerator, and the n to the negative 4 goes down into the denominator. So that's what I get after that step. And now I'm going to do the multiplication rule where I have repeated bases beside each other, in which case I add the exponents together. So I have an m cubed and an m cubed. That's going to give me m to the 6th. Then I have an n cubed and an n squared. That's going to give me n to the 5th when I condense. And the numerator stays the same. Okay, and lastly, I'm going to use the quotient rule to get rid of repeated bases that are in the numerator that are divided in one in numerator, one in the denominator. So I have 6 m's up above, 4 m's below. I can cross out 4 of them, and that gives me 2 in the numerator. And then here I have 5 up above and 4 down below. I can cross out 4 of them, leaving me with 1 in the numerator. Now, if nothing's left in the denominator, you can either really write it, think of it as division by 1, or since dividing by 1 does absolutely nothing, you can just get rid of it altogether. And also, if you have n to the first power, that's the same thing as just n. So that would be my solution. Okay, so write each expression in radical form. So when I do that, the 4 goes out front and becomes the index of the radical. So I'm going to get the 4th root of 5m, and then the numerator becomes the exponent. So that's the 4th root of 5m to the 3rd power. Okay, solve using radicals. Okay, so this is the same, similar to solve by taking square roots, except I do the inverse operation of cubing something, and that's taking the cube root. So I want to get a number on one side of the equation. Okay, so to do that, I'm going to add the 2. So that's going to give me 8x cubed equals 1. Now I'm going to divide by 8. So I'm up to x cubed equals 1/8. So the reverse of cubing something is taking the cube root. So I'm going to take the cube root of both sides. Okay, the cube root of 1/8 is the same thing as the cube root of 1 over the cube root of 8. Well, the cube root of 1 is 1. The cube root of 8 is just 2, because 2 times 2 times 2, 3 of them multiplied together gives you 8. So that means I can simplify and just end up with 1/2 as my solution. Okay, next, solve another one, solve by taking square roots. Okay, so I'm going to divide by 4, and that's going to give me a minus 2 squared equals 1/4. Now I'm going to do the reverse operation of squaring, and that would be taking the square root. I get a minus 2 equals. Now, square root of, and I can't forget the plus minus. The square root of plus minus square root of 1/4 is going to be plus minus square root of 1 over plus minus square root of 4, which is just, and the square root of 4 is just 2, and the square root of 1 is 1. So now I'm up to this. Okay, and then lastly, I'm going to add 2 to both sides. So I get 2 plus or minus 1/2. All right, so now I'm going to write that as an improper fraction. So to write that as an improper fraction, I need a common denominator when I add or subtract. Okay, so this is going to give me 2 plus 1/2, and the other one is 2 minus 1/2. So 2 is the same thing as 4 over 2 plus 1 over 2 is equal to 5/2. And then here I'm going to write 2 again as 4 over 2, and then I'm going to do minus 1/2, and that's going to give me 3/2. So my two solutions are 5/2 and 3/2. Okay, next one. Let's see. Solve each equation, checking for extraneous solutions. Okay, so in the first one, I have a radical equation. So to solve it, I need to get the radical on one side of the equation, and then I need to do the reverse operation of what that radical is. So I'm going to divide by -8, and I get the square root of b minus 3 equals 4. So I'm taking the square root, so the reverse of taking the square root is squaring. So I'm going to square it, and I get b minus 3 equals 16. All right, and then I'm going to add 3 to both sides, and then that gives me 19. So, yeah, that's the right answer if I check myself. Okay, convert into radians. Okay, so convert into degrees. So I use the ratio that is 2 pi radians is 360 degrees. So that's going to cause, now I have two fractions I'm multiplying together. The pi's cross out. I get 7 times 360 divided by 4. Okay, if I do that on my calculator, I'm going to find out that that is 630 degrees. And that's one time around a full 360, and then another, 270 beyond that. Okay, to go into radians, I do the reverse. I say, okay, 360 degrees is 2 pi radians. Okay, now I have a simple fraction, and I multiply across. I get 210 degrees over 360 degrees. And I can reduce that fraction. First of all, divide by 10. And now I'll divide by 3. I get 7 twelfths. Oh, and I can't forget, I'm sorry, not degrees. The degrees cross out, leaving me with radians. So that's, and I can't forget the pi. Duh. So that gives me 7 pi over 12 radians. Okay, number 18, solve the equation. Okay, so once again, it's a radical equation. I need to get a number all by itself on the right side. So now I'm going to do the reverse operation of taking the fifth root. And that is raising both sides to the fifth power, because that's going to cause the radical to disappear. I'm going to get 16k equals, now 2 to the fifth power is 2 times 2 times 2 times 2 times 2. I think it ends up being 32. Yeah. All right. And then lastly, I divide by 16. And that gives me k is equal to 2. And that's my solution. Okay, here I have a rational expression to simplify. So when I want, this is division, so I know that I'm going to end up flipping the numerator and denominator of the second term. So why don't I do that right off the bat? I'm going to rewrite the second term as that instead. And now I have a multiplication problem. Okay. So now the next step is always just to factor everything. So I want to try GCF factoring first. So up here I can see I can factor out 3v. So that's going to give me v squared minus No, I'm sorry, I can factor out 3v squared. So that's going to give me v minus 10. So that's this. The denominator here, I need two numbers that multiply to be negative 20 and add up to 1. That would be v minus 5 and v plus 4. Then over here, I'm going to have 8v squared is already factored. And then here, I can factor out 8v squared times v minus 10. Okay, now I can go through and I look at numerators and denominators and I cross out common factors. So the v minus 10s will cross out. The 8v squareds will cross out. And I think that's it. So that is going to give me 3v squared times, or divided by, I should say, the product of v minus 5, oops, and I did a typo here, this is v plus 4, times v plus 4. Okay, so that's that one. And then the last one, I think, is, okay, so this is a subtraction. I'm subtracting fractions, so I need a common denominator. So the way I get the common denominator is I take that denominator, I write it over itself to multiply the second fraction by that, and then I take whatever's in there and I multiply the first fraction by that over itself. And then I add or subtract the numerators and keep the common denominator. So when I do this, I'm going to get, let's see, the numerator, first of all, is going to become 6v, and I'll just write the whole thing out, over 12u minus 12uv over 12u. And now I have a common denominator, so I subtract the numerators, and I get 6v minus 12uv over 12u. Now, I'm not quite done because I can see I have a common factor of 2 that I can factor out of every term. So if I divide everything by 2, I end up with 3v minus 6uv all over 6u. Oh, and now I can see I can divide out a 3. So I'm going to divide out the 3. Get v minus uv over 2u. And that would be my solution. Okay, so those are the 20 multiple choice problems. The ones on the quiz are or the final exam are very similar. I modeled each question after a similar question on the exam. So hopefully, actually that's mostly Algebra 1 and a little bit of Algebra 2 with factoring higher order polynomials and higher order equations, and also imaginary solutions. But other than that, it should be pretty straightforward, and then the radians and degrees is just a little taste of what trig is going to be about if you take trig or pre-calc. All right, hope this was helpful, and we'll see you in the next screencast. Cheers.